Let's look at this specific example involving a trigonometric function. It's actually f of x equals cosine of 1 over x. What we're going to do here is create a table of ordered pairs and try to find a couple of patterns. We're going to begin by adding 3 more ordered pairs than what I intended. So let's put 3 more in here. Let's start with 1 over pi. And then we'll work our way to a number. We're going to get smaller and smaller. So we're going to do 1 over 2 pi, then 1 over 3 pi, then 1 over 4 pi, and so on. Now the goal here is to evaluate this using your trigonometry experience. You're doing this without a calculator. And we're simply going to evaluate the function value. F of 1 over pi is going to be the cosine of 1 over pi, which is simply the cosine of pi, which is equal to -1. Now let's look at another expression. Let's look at f of 1 over 2 pi. That will simplify into cosine of 2 pi. And that is because when you divide by a fraction, you multiply by the reciprocal. Now that's +1. And if you continue with this pattern, hopefully you find some patterns living inside another pattern. And if you continue in this manner, you're going to realize there are some y values that are bouncing up and down. It goes from -1, then to 1, then to -1, then to +1. And we'll go ahead and fill in that t-table. And you could even graph this with using a graphing calculator or Desmos.com. And what's happening is as x is approaching 0 from the right, there's a lot of y values bouncing up and down. So notice that your x values are approaching 0 from the right. Go ahead and fill in that blank there. Write 0. As x values approach 0 from the right, we're getting some different y values. You know, sometimes the y values are at +1, sometimes they're at -1. There's also y values in between. They are bouncing up and down very, very, very fast. And it turns out that as x approaches 0 from the right, the corresponding output values are not approaching a finite number. So what can you conclude about the limit as x approaches 0 from both sides? Well, since we're looking at it even from a one-sided standpoint, we know that this limit does not exist. So let's go ahead and give a brief explanation here. The limit as x approaches 0 from both sides of the cosine of 1 over x does not exist because we know that the limit as x approaches 0 even from the right-hand side of this function, cosine of 1 over x, does not exist.